Yes, anybody there? Is there anybody listening? Anybody listening from anybody listening? Hello? 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 Do you listen to me? Hello?
Hello, sir.
Why you write on the board? Somebody is writing on the board. It is creating a trouble for me. Why should somebody write on the board? Tell me that. Hello. You see, he has drawn some lines on the board. Okay, thank you for removing. Okay, thanks a lot. Don't write on the board. Why you write on the board? Yes. Now it is a second lecture on circular motion. Again, the lecture is for cbse exam or board exam. And point number one that I want to discuss today is non-uniform circular motion. Non-uniform circular motion. Non-uniform circular motion. Please listen to me carefully. Yes? Yes? Non-uniform circular motion. So, what is the single most important point for non-uniform circular motion? One single most important point in non-uniform circular motion is that non-uniform circular motion or in non-uniform circular motion, there is tangential acceleration. That is all. There is tangential acceleration. In addition to centripetal acceleration. In addition to centripetal acceleration. It is the basic point. This is the basic point. That is all. Now, due to additional tangential acceleration, there are so many things which happen, but those things follow from the tangential acceleration. But the only important thing is that in non-uniform circular motion, there is tangential acceleration. So what happens due to this tangential acceleration? Please listen to me carefully so that we do it in a very simple way. The simple way is this. Have a look. When a particle moves in a circle, if I can make a circle in a nice way. This is a particle. It has a velocity v, right? There is an acceleration towards the center that you know in circular motion. Definitely there must be acceleration towards the center. That's AC, centripetal acceleration toward the center where the particle moves in a circle. But now in uniform circular motion, the speed was constant. The speed was constant. Yes. The speed was constant. In non-uniform circular motion, the speed was constant. When this speed was constant, then tangential acceleration was zero, because when tangential acceleration is the rate of change of speed, then this speed was constant. That simply means tangential acceleration was zero. But in non-uniform circular motion, there is tangential acceleration also. Yeah, that is, there is acceleration in this direction, there is acceleration in this direction. This acceleration makes the particle to move in a circle, and this tangential acceleration increases the speed, right? And you already know that tangential acceleration is equal to dv by dt, rate of change of speed. Obviously, when speed is constant, then tangential acceleration is zero. So in uniform circular motion, you already know that speed was constant, therefore at was zero. There was only this ac, and ac, you know, that is v square by r. Okay, now in non-uniform circular motion, there are two accelerations, at and ac. So what is the net acceleration? Net acceleration is resultant of these two accelerations, that is in this direction, that is a, and that a is equal to root of at square plus ac square. Why? Because it is the resultant of these two rectilinear components. And what is the direction that this a makes with the radius vector? R or AC. AC and R has the same direction, radius vector. What is this theta? And you know, if you make it this from this triangle, tan theta is equal to perpendicular, that is AT, by base, that is AC. Now theta is equal to tan inverse AT by AC. So what we have learned is that in non-uniform circular motion, the net acceleration is not towards the center. It makes angle theta with the radius vector. In uniform circular motion, you already know that the net acceleration was towards the center, because there was only one acceleration, that was AC. But in the present case, there are two accelerations, AT and AC. AT is the tangential acceleration, which increases the speed, and AC is the acceleration which makes the particle to move in a circle. And now the net acceleration is not toward the center. It makes angle theta with the radius vector given by this, right? Okay, number one. Number second, when there's tangential acceleration, that implies speed changes. Means this speed, okay, changes. If this speed changes, what happens to omega, angular velocity? Let us see. Let us see what happens to omega. Because when the particle moves in a circle, it cuts angle about the center. So the rate of change of that angle is omega. Let us see what happens to omega. Now we know speed is equal to r omega. This means the speed changes, omega should also change if r remains constant from this equation. So in non-uniform circular motion, angular velocity also changes. But if you concentrate very sharply, it is it is speed which changes, because there is tangential acceleration that makes the speed to change. That also leads omega to change. So what we have to do, we have to only remember that there is tangential acceleration. From there, we can have so many conclusions. Now, if we differentiate this equation, what we get? dv by dt is equal to r d omega by dt, that you already know. And this is nothing but tangential acceleration is equal to r, that is alpha. Tangential acceleration is equal to r alpha. So now, can anybody of you tell me? Can anybody tell me that what is force? How much is the force on a particle moving in a circle with non-uniform circular motion? Here it is tangential acceleration. Here it is centripetal acceleration, AC, towards the center. And this is the net acceleration. Okay. Now, can you tell me what is tangential force?
md by dt.
Can anybody tell me what is
By dt.
Can anybody tell me what is tangential force? MAT. Is that right? Mass into tangential acceleration. And if you substitute for AT, that is alpha or just we have found that. Now, can you tell me what is the FC force towards the center? Anybody can guess? That is mv square by r, right? That is m r omega square. Can you tell me what is the net force? Can anybody tell me what is net force?
Under root of ft square.
Yes,
Plus fc
that is
square.
nice, but don't make noise. That creates a problem for me here. Otherwise, you see, you should switch off your that audio. It is ft square plus fc square, right? Now, one more point. Can anybody tell me what is this force? What angle it makes with the radius vector or even with the horizontal? That is theta is equal to tan inverse. Yes. Perpendicular. That is ft. This force by base, that is fc. It is the same as earlier theta, what the acceleration makes with the radius vector. The net force also makes the same angle with the radius vector. If you have to find angle with the horizontal, this, then it is simply tan inverse fc by ft. इसका उल्टा, इसको उल्टा करके वो एंगल निकलेगा ये एंगल. Okay. Now let me ask you a question. Can anybody tell me what equation one can write for speed of the particle? I'll be very happy if you give me the answer. Can anybody tell me that? What equation you can write for the speed of the particle? Yes. So I will tell you that. Speed of a particle is, this particle moves in a circle, moves in a circle, moves in a circle, moves in a circle, and it covers distance, it goes on covering the distance. This distance it covers distance, curvilinear distance it covers. The distance it covers per unit time is speed, that is all. It is not displacement. Suppose, you see, okay, I will try to explain you that in a moment. Because in these problems and in questions, these simple things become very important. And students make very small mistakes. See here, a particle is moving like this. And particle goes from here to here. This is S distance covered, and this is displacement here, R. Yeah, delta R is better. Yeah, delta S.
सर क्या ये 2 pi angle है या circumference है 2 pi r ये distance?
Yes, obviously 2 pi R is the distance, total distance, but I don't talk of total distance. I talk about part of a distance. If you are asked what is the speed here, average speed from this point to this point, it is delta S by delta T. If I ask you what is velocity from this point to this point, It is delta R by delta T. That's absolutely right. But if I ask you what is speed at a point, यहाँ पर speed क्या है, यहाँ पर speed क्या है, किसी point एक point पर speed क्या है, not average speed from here to here. That is very easy. You can just find the distance covered by divided by the time interval. Then you can give me the average speed. But I ask you, what is the instantaneous speed? That is just v speed is equal to ds by dt. And instantaneous velocity is just dr by dt. But dr and ds is the same thing in magnitude. It has only direction. It does not have direction. So particle यहाँ पर है, तो इसका velocity का direction ये है. Speed का direction नहीं है. So here it is very important to say, whenever you want to find speed, आप distance का differentiation कीजिए. और अगर आपको velocity चाहिए, तो आप displacement का differentiation कीजिए. That's what is very important. Okay. Now let me go to one more concept.
सर स्केलर उसका डिफरेंशियल होता है?
Yes.
स्केलर उसका डिफरेंशियल होता है. स्पीड इज अ स्केलर क्वांटिटी. क्या इसका डिफरेंशियल होता है, एग्जिस्ट होता है?
इसका डिफरेंशियल, इस स्केलर का डिफरेंशियल होता है, ये कहते हो? दिस इज द क्वेश्चन यू आस्क.
जी सर.
हाँ ठीक है. ओके. चलो मैं आपको थोड़ा सा एग्जांपल देता हूँ. आपने कभी नहीं देखा कि वर्क इज स्केलर? Don't you know that?
Yes sir.
Don't you know power is equal to dw by dt? एनर्जी का डिफरेंशियल होता है बाज़ाब्ता वॉल्यूम का. अरे यार, let me give you the answer. Scalars have differentials. This question shouldn't have been asked by you. Okay, scalars have differentials. This question shouldn't have been asked by you. आपने asked, now you ask the question. My answer is yes, scalars have differentials. You are attending a lecture online. You should not ask silly questions, बेटे. ये शायद नेशनल लेवल पर भी ये लेक्चर्स वॉच होते हो तो they will make a fool of us. Okay, चलिए ठीक है. Now, what about the centripetal force? That is mr omega square. What about the tangential force? That is mat. Now let me make some concepts clear to you here. When a particle moves in a circle, if I ask you, what is the centripetal acceleration? The answer is, again, it is towards the center and its value is v square by r. If I ask you what is the tangential acceleration, say at is equal to r alpha. If I ask you what is the net acceleration, then you can say, you can take the what you call as resultant of these, make a parallelogram or a rectangle, whatever you या तो rectangle ही बनेगा, तो you take a resultant of this, that is acceleration. ठीक, this is theta. That's all. Because you see, even in non-uniform circular motion, the centripetal acceleration continues to have the same equation. That's my point. I will write it down. Even in non-uniform circular motion, even in non-uniform circular motion, even in non-uniform circular motion, the centripetal acceleration is equal to v square by r or r omega square. That's all. If I ask you just this question, what happens to momentum in non-uniform circular motion? Yes, it changes. What happens to the magnitude of momentum? Changes. Why? Because speed also changes. In uniform circular motion, P vector magnitude does not change. The constant. In uniform circular motion. Now, can you tell me, is any work done in non-uniform circular motion? Is work
Zero.
done? Is work done in non-uniform circular motion? I will like your answer if you give me. Yes. Will work be done?
Zero.
Zero. देखो पार्टिकल है ना, ये टेंजेंशियल फोर्स है, ये सेंट्रिपिटल फोर्स है Fc. Will work be done? The answer is yes. Who does that work? Ft does that work. Does the work. Because Ft has the same direction as velocity. And Ft and V have the same direction. Therefore, this is what does the work. You know already work has the formula F dot S. If force and displacement are perpendicular to each other, then there's no work done, because if the angle between the displacement, this is the direction of displacement, because particle moves in this direction, speed or velocity has this direction. The angle between this force and the velocity is 90. Therefore, work is not done by Fc. Work is done by Ft, because the angle is zero. It is Fs cos of zero. Fs cos of zero, right? That is Fs. Means this Ft does work. You see, let me put the things as simple as possible, and let you remember as many things as possible.
What?
Fc, I will write Fc.
Kaya sa Tantray na awas
Fc, the centripetal force, does no work. Ft does work. Right? And this Ft increases the speed. And you know, this work is equal to change in kinetic energy 1 by 2 m Vf square, final velocity square, 1 by 2 m V initial square. अगर kinetic energy बढ़ जाता है तो work हो रहा है, लेकिन अब question ये है कि who does the work? This Ft does the work, because Ft is tangential to the tangential force. It increases the speed, and when speed increases, definitely work is being done. That's all. You please note these points; they're very important points. Okay, now let me go to the third point. Third point is, you may have heard about banking of roads. Banking of roads. Banking of roads. You know, when you negotiate a curve on the road, you may have seen the road is banked from one side. I mean, the roads are like this. The roads are like this. This is the road. It is not this road, downslide road. Road is just out of the screen. Road is out of the screen. Okay, I will try to make another figure so that you understand. I'll make this figure. This is the road. This is the road. Not up and down, cross. This is the road. It has been banked. I mean, it has gone up. This is the road. I will make one more figure so that you understand. This is the road. You may feel this is the road, but no, this is the road. It is banked from this side.
Sir, जो आप
Okay? Acha. Now say, why these roads are banked? That's the yes.
क्या work done होगी net work done due to tangential force net work done in a
Yes.
circular.
Yes. Yes. Now the question is, why should there be banking, and how much should be the banking angle? That's what we have to do. Have a look. See here. Here is the vehicle. I mean, maybe it's a car, maybe it is a truck, any vehicle. It moves in a circular path like this. Circular path it is not moving down the incline. It is moving on the incline like out of the board, and it moves in a circle like this with a radius r. For this vehicle, we need a force in this direction. How much force we need? We need a force mv square by r force. That is the need for a circular motion, because when a car moves on a circular track or on a patch, it needs a force toward the center. I mean, we need a force on this car toward the center O. So who will provide this force? The question is that there are so many forces acting on the car, but we will try to understand what amount of force is in this direction that provides this force. That we have to see. First force is mg downwards, that is gravitational force. And this incline the road produces a normal reaction in upward direction. If I put it dot like this, this theta is the same as this theta, and it is the same as this theta. This n normal reaction perpendicular to this plane can be resolved in two components. Here it is, in this direction is n cos theta, and in this direction is n sin theta. And this mg can be, it needs not to be resolved. It needs not to be resolved because mg is vertically down, n cos theta is vertically up. And in this direction, we need n sin theta force. And this n sin theta force provides this mv square by r, so that your car negotiates the curve in a successful way. If there is no banking, this n will not be resolved into components, and you will not get a force mv square by r for negotiating the curve. So what are the equations that I can write? This n sin theta provides what? It provides the centripetal force, that's mv square by r for circular motion. Had there been no n sin theta, this mv square by r will not be provided, and the car cannot move in a circle or on a part of a circle. Now, for balancing of weight, what should I write? N cos theta. That is upward force. It is being balanced by the weight, mg. Dividing these two equations. Dividing, we get. What we get is tan theta when we divide, right? When we divide, tan theta is equal to m v square by r divided by mg. This gets cancelled. It is v square by rg. So theta, the banking angle, is tan inverse v square by rg. This is the angle that is set by the engineers on the banking, on the curved path. Suppose v is velocity 40 km/h. You have that radius of that curve at that point of the road. That is given. G is given. You substitute these values and get the value of theta. Suppose value of theta is something like 15 degrees or 10 degrees maybe. If your speed then is more than 45, for which the angle has been set. If your speed is more than 40, then let me explain it once again. Have a look. Speed is set to be 45 km/h, and r is given to be, suppose whatever this there r radius of that curve of that arc is, okay, whatever. G is 10, and you set the angle theta, suppose 10 degrees. Now, if your speed is more than 45, then what will happen? Theta is fixed. So that means for that velocity, for that speed, you will move in a radius of greater radius. You will move in a curve of greater radius. मतलब आपको यहां से जाना था, had your velocity been 45, लेकिन अब आप यहां से जाओगे greater radius से, वहां से रास्ता तो होगा नहीं, you will skid off. So that is why you always slow down when you negotiate a curve, or when there is written road signs, go slow, the curve is ahead. So that's why you move in your motorbike or in your car, you move very slow on a curved path, so that you don't skid off. Because of this reason, theta is fixed, and your velocity has to be smaller to negotiate the curve of that radius. So you remember this equation, okay? But here I have neglected friction. Friction also supports you to negotiate the curve, but I have not. You see, I have not included friction, because friction you have not read. If friction is also taken into consideration, what will happen? Can we do something about that? Okay, let me take friction into consideration. Third point, if friction is taken into consideration, friction is taken into consideration. I have not taught you friction so far, but I must tell you the maximum frictional force is, suppose it is a body here and its normal reaction is N and it moves in this direction, let me suppose, or it tends to move in this direction. The friction force is backward, F, that is mu, coefficient of friction between this surface and this normal reaction. This you have to remember for the time being. The maximum friction force is mu, that is the coefficient of friction between the two surfaces, and normal reaction. If normal reaction is more, the frictional force is more. So when you are negotiating a curve, frictional force also helps you to keep your balance. As you must know, if the road is slippery and the road has a curvature also, then the chances of accident are much higher. Okay. So what should I do? Have a look. I will tell you. I can take this. This is the road. Magar road is going out of the board. It's coming out not like this. The road is not like this. That will be a misconception. Road is coming out of the board. Now, this is the car or the vehicle, and you need a force in this direction. It is moving in a circle like this. It is towards the center. I need a force, and you know how much force I need to move the body in a circle. That's mv squared by r, as you know, yeah, m r omega squared. Now, suppose its velocity is something and it has a tendency to go in. यहाँ जाने का tendency है, तो frictional force will act in this direction. So if it has a very small velocity, it will skid in. When it tends to skid in, the friction force will act opposite. Mu n will be the frictional force, maximum frictional force. So mg is down, normal reaction is up like this, and this is theta, this is also theta, and now okay, so okay, let me, this also theta. Can you resolve this? Can you resolve this frictional force into components? This component is mu n cos theta, and this component is what? Mu n sin theta. And n into components, this is n sin theta, and this is what? N cos of theta. Now, can you write down the equations? I need force in this direction towards the center. What is the force? which I have in this direction, that is n sine theta. You see, have a look, minus mu n cos theta. This force minus this force is net force on this toward the center. This force minus this force is the net force towards the center. That is minus mu n cos theta is equal to mv square by r. Right? Now, these two forces balance mg. So what are the upward forces? N cos theta plus, yes, mu n sine theta is equal to mg. Right? If I divide these two equations, so what I am going to get? N cancels, so it is sine theta dividing, let me write, dividing the two equations. We get, what we are getting? Sine theta minus mu cos theta, because n cancels off with the denominator, is cos theta plus mu sine theta is equal to mv square by r by mg. This gets cancelled. It is v square by rg. Is that right? Okay. Now see here, one more interesting thing here. What is v square? Now, get rg here. Rg into sine theta minus mu cos theta by cos theta plus mu sine theta. And v equal to root of rg sine theta minus mu cos theta divided by cos theta plus mu sine theta. This is the velocity, minimum velocity. This is minimum velocity. If your velocity is less than this, then you can stick it in. You can stick it in. If velocity is more than this, then it's all right. But if the velocity increases, then this frictional force will reverse direction, because in that case the vehicle will try to stick it away in this direction, and the frictional force will reverse the direction. If it tries to go in this direction, the frictional force will try to keep it inverse. That frictional force will support it towards the inside. So that simply means this is the minimum velocity. What should be the maximum velocity it can sustain without skidding? Maximum velocity is equal to root of rg. Yes, can you guess? Sine theta plus mu cos theta, because the direction of friction force will change. That this mu has to be negative. When this is negative, it will become positive. Divided by cos theta minus mu sine theta. So you had to replace mu by minus mu. You have to replace mu by minus mu. Have a look. Okay, let me again try to explain you this. अच्छा, और देखो, interesting चीज देखिए आप. Suppose keep mu is equal to 0. There's no friction, right? If there's no friction, right? This will become 0. This will become 0. This will become 0. This will become 0. This will become tan theta. So v square is equal to rg tan theta. Tan theta is equal to v square by rg. You are back to square 1. You already have that good equation when there's no friction. But when there's friction, this is the good equation. And you see, why I call this minimum velocities. Now see here, I will try to show you something. This is, you see, this is theta and this is vehicle here. If its velocity is very, very less and it is on the incline, and velocity is very, very less, it can stick it like this. अगर इसका velocity कम है तो अंदर जाएगा. तो ये वेलोसिटी होना चाहिए कम से कम. अगर इससे कम हो तो अंदर जाएगा. अगर इससे ज्यादा है तो बाहर की ओर स्किड हो जाएगा, इससे कम है तो अंदर की ओर स्किड होगा, इससे ज्यादा है तो बाहर की ओर स्किड होगा। तो वेलोसिटी एक व्हीकल का इन दो के दरमियान होना चाहिए, ग्रेटर देन वी मिनिमम एंड लेस देन वी मैक्स। वी मिनिमम निकाला तो म्यू को सिर्फ रिवर्स करना है तो ये आपको मिल जाएगा, दैट्स ऑल। So this is a question that can be asked in the exam to derive the expressions for this, right? Okay. So tomorrow's lecture will be for NEET classes. Tomorrow's lecture will be for NEET classes on circular motion. That will be on application techniques for NEET people, NEET students, those who want to prepare for NEET. Two lectures from tomorrow. 2 lectures from tomorrow. That will clear their NEET. इसमें application techniques plus NCERT plus SC Verma problems and objectives. And there'll be 2 more lectures that will for JE class. Okay, I will stop the lecture now. Stop. Yes.
सर हमने आपसे
क्या
हमने सर कल आपसे कहा था ना वो टाइमिंग
क्या करो
टाइमिंग।
हाँ बेटा वो देख लेंगे इंशाल्लाह, 2-4 दिन के बाद देख लेंगे, कोई बात नहीं। कि आप इसको फिर मैं अपलोड भी करूंगा तो अपलोड के बाद भी आप देख सकते हैं।
ओके,
डोंट बॉदर।